So today we finish up a couple topics from last week, which is labor and core relief, and then we have banking. There's a new handout for today, but we only need table 1 for today. Most of the tables for today come from last week's handout. What else do I want to tell you? Your problem sets due Thursday as you walk in. We'll have little things there where you can put it in a pile with your TA's. Make sure your TA's name is on your problem set. As you turn it in, and you'll put them in one of 3 piles. First midterm is a week from Thursday. The rooms are up there on the board. Who's here? Eric's students will take it here, and Rachel and Andrew's students will take it in 10 Evans. So, do y'all have any questions before I get started? I think that's all. I think we're ready. We almost ready? Cool. Let's rock and roll. Oh. All right, here we go. Labor market. So on Thursday when we were last here, we started looking at antebellum labor markets. The economic tool that we're going to use is just your standard supply and demand for labor. So the neoclassical model of labor. Whoops, sorry. Forgot to put on my pen. And that one is the one where we put the wage on the vertical axis, the quantity of labor on the horizontal axis, downward sloping demand for labor, which reflects the marginal revenue product. It assumes that businesses have as their goal maximizing profit, and they're choosing to hire the number of workers that will maximize their profit. Their demand for labor, therefore, is a reflection of the additional revenue that the workers add to the firm. That additional revenue is, in turn, a reflection of the combination of the price of the output and the physical productivity of the worker. Okay. And then we've got an upward sloping supply of labor. The supply of labor represents people's choices in terms of the trade-off between working and not working, or what economists call labor and leisure. That labor-leisure trade-off is undertaken with the goal of maximizing utility. Utility is increased by working because working provides income with which we can buy goods and services. On the other hand, utility is decreased by working because working is a pain in the butt. So there's a trade-off there between working and not working. Working allows you to buy stuff. That means you have less time to yourself. And it works out to be generally upward sloping. There are times when it's a backward bending supply curve, but never in times that are of interest to us. So we're going to skip the backward bending part. Equilibrium would be at some equilibrium wage, I'll call it W1, and some equilibrium quantity Q1. An implicit assumption of this model is that labor is homogeneous. One worker is substitutable perfect. Each worker is a perfect substitute for each other worker, or one worker is a perfect substitute for another worker, however you want to say it. So it's okay to use this to describe the determinants of wages for a well-defined occupational category. It's not a good model to use to understand the determinants of the demand for labor generally for the economy as a whole. Yeah. Yes. We assume the question is, do we assume that the supply of labor is always increasing in wages? There is a possibility of a backward bending supply curve, so it goes up and then it bends back. But it's particularly here we're talking about antebellum labor. We're not going to be at high enough levels of wages for people to encounter the backward bending part of the supply curve. So in theory, it can bend back. In practice, in what we're observing, we're not there. All right. Excuse me. I used this a little bit on Thursday to talk about the difference between male and female wages and the use of female labor in New England. And the idea there, I didn't leave room to draw this. That was really silly. Let me open just a blank screen. The idea there is that, again, we've got wages on the vertical, quantity of labor on the horizontal. And if we look at the supply of labor curve, the supply of labor slopes up. So I'm going from the upper right down. It's going to go down until it reaches some minimum point, which is the reservation wage. And that reservation wage is the minimum wage that someone will accept. Once the wage gets down below that reservation wage, then the quantity of labor that's supplied is 0. So the supply curve pops over and hits the vertical axis once we reach that reservation wage. The notion is that we can do a male-female comparison and we can do a New England Mid-Atlantic comparison. So particularly for women in New England, their reservation wage, which is determined in large part by your opportunity costs, the reservation wage for women in New England in the antebellum period was quite low because the opportunities for earning alternative income were largely farming, but farming in New England was difficult to do, long winters, rocky soil, and so on and so forth, 40 inches of snow in Connecticut, things like that. And so the reservation wage for women was typically lower than the reservation wage for men. So if we put here a second reservation wage, which would be the reservation wage for men, that's typically higher because men have better opportunities to make other income in farming or in other occupations. So for men, if it was the same quantity of labor, their labor supply curve would come down only as far as their higher reservation wage, and then it would pop over to the vertical axis and again drop down to 0. So in that case, if there are jobs that are low-skill jobs, that is, there are jobs that require a low level of skill where the workers have very low productivity, the low level of productivity means that the demand curve is quite far to the left relative to the origin. And so if you've got a low productivity job, you're going to have a demand for labor curve that's way over to the left. And you can draw it in such a way where if you get your demand for labor curve far enough to the left, it's not going to intersect the supply of labor in the range where men are willing to accept the wage. That the wage is below the reservation wage of the men, but above the reservation wage of the women, which are different because the opportunity costs for men in terms of alternative ways of earning an income were greater than the opportunity costs for women. So it explains both why they're using women in New England in farming and why the ratio of women's wages to men's wages were as low as they were. We're going to use the same basic model to understand a few other facts about antebellum labor. So going to the next slide. So this is table 9. Again, this is from the handout from last week, table 9. Table 9 is showing us an index of manufacturing wages. So here we're looking at wages that are paid to workers who are manufacturing goods. And these are real wages, so they've already been adjusted for inflation. Increases, therefore, in the wage are an increase not just in prices, but an increase in purchasing power. So we want to notice a couple of things about the data here in Table 9. The first thing that we notice is the increase in real wages from 1820 to 1830 to 1850. So there's pretty dramatic increases in wages for people who are working in manufacturing over this first half of the 19th century, rising from an index value of 101 to an index value of something between 155 and 197. There's a range there because the evidence does not allow us to come up with just one value. So it's someplace in that range. The increase in wages that we see here in Table 9, we can explain again with that same basic model because the increase in wages is happening at the same time that productivity is rising. So again, wages on the vertical, quantity of labor on the horizontal, an upward sloping supply of labor curve, a downward sloping D1 for the first demand for labor curve. That's going to give us some initial wage rate W1, and then the increase in productivity, which came about in the first half of the 19th century as manufacturing workers had more capital to work with, so you had substitution of capital for labor. As workers have more machines to work with, that increases the productivity of the workers. Those increases in the marginal product of the workers take and shift the demand for labor to the right. Oops. Choose some color. Gives you a second demand curve, I'll call it D2, to the right of the first demand curve as a result of the increase in productivity, and those increases in productivity are passed on to the workers in the form of higher wages. So we get the increase in wages out of our model that we see in the data, it comes as a result of the increase in productivity. The second thing that we can see in Table 9 is we've got comparisons here of Mid-Atlantic and New England, and we've got both urban and rural wages. And so we can look at the ratio of the urban, excuse me, this is hard to say, the urban wage to the rural wage, I feel like Scooby-Doo, the ratio of urban to rural wages, and we can compare either over time or we can compare Mid-Atlantic to New England. The first thing to notice is if we're looking here at the Mid-Atlantic region, which is the top half of the graph, that the urban to rural ratio is generally greater than 1. So that fact that the urban-rural ratio is greater than 1 tells us that urban wages, again, these are real wages, so they're adjusted for inflation, that wages in the urban areas are greater than wages in the rural areas. So you're going to make more money living in the city than you are living in the country. Question of high. Yeah. Which number you want me to look? This 199? The 199? The Mid-Atlantic region is very, very fertile land, agriculturally fertile land. And so the productivity of the workers in the rural areas is quite high, and therefore the wages are quite high. So that's why the rural wages are going to be higher in the Mid-Atlantic region. I wish we had a better word than rural because I'm going to just rural. That's why the rural wages in Mid-Atlantic are going to be higher than the same thing in the New England country wages. Sure, country. Boonies. Okay. So explaining this urban to rural ratio and why in particular this urban to rural ratio here in the Mid-Atlantic region is declining slightly over time. So you can look at the first number. It goes from 1.1 to 1.0 to 0.8. You can look at the last number from 1.5 to 1.6 to 1.1. Generally, we've got this downward trend. So that the premium for being a worker in the city is decreasing over time. So you had a bigger premium for moving off the farm going into the city in 1832 than you did in 1860. How come? Well, we can use the same basic model to try to understand that as well. Here again, I'm going to put wages on the vertical axis, quantity of labor on the horizontal axis, start with some downward sloping demand curve, D1, start with some upward sloping supply curve, S1, find my initial wage, W1. And the key event here that we want to take account of is the migration pattern. We looked at migration the other day. The migration pattern in this antebellum, pre-Civil War period, is largely laborers. And it's largely laborers who are moving to the cities. So that the bulk of the immigration is moving into the urban areas. And so you get an increase in the supply of labor in the urban area. That increase in the supply of labor in the urban area is not matched by an equal-sized increase in the supply of labor in the rural area. So if we had the same proportion of people going into the rural and the urban areas, I wouldn't have a story. But because a disproportionate share of our international immigrants are going into the urban areas, that's one piece of information. The second piece of information is the transportation improvements that we looked at previously. Those transportation improvements are lowering the cost of internal migration, that is moving around within the country. That lowering of the cost of internal migration, one of the factors we talked about that leads to migration, that lowering of the cost of internal migration, that also is leading to a migration of folks who are already in the United States from the rural areas to the urban areas. So both the international migration is disproportionately to the cities, and the internal migration is from the country to the city, both of which give us a disproportionate increase in the supply of labor in the urban markets. And that disproportionate increase in the supply of labor in the urban markets is going to drive down the wages in the urban markets, all else constant, that is relative to the wages in the rural markets. So the closing of the gap between urban and rural wages, 1830 to 1860, is largely a reflection of the disproportionate migration across the oceans into the cities and out of the country into the city. We can show it with this shift in supply. Another factoid, yeah. There are shifts in demand for labor in both urban and rural, but the explanation of why that urban-rural gap gets smaller comes from this disproportionate change in the supply. So you can draw, I could do this over and I could draw an urban picture and a rural picture and I could have a change in demand in both, but the changes in supply swamp any demand effect that we may have and explain the closing of the gap. Yeah, sure. All right, last factoid. Comparing wages in the United States to wages in England. This table is an index. These are index numbers once again, which means that, look here in the top of the table, it says the wage in England is set to 100. So we don't know what the actual wages are, but we are looking just at a comparison. So if the wage in England is 100 for a skilled carpenter, the wage in the United States was 150 for a skilled carpenter. If the wage in England was down here 100 for a common laborer, the wage in the United States for a common laborer was 135. So you can read the numbers in this table as giving you how much greater is the wage in the United States than it is in England. So if the wage, for instance, is 150, that means that the U.S. wages are 50% greater than the wages in England. In most cases, workers did better in the United States than they did in England. So this is one of the factors that's going to go back into our discussion of migration. One of the pull factors to come to the United States is that the wages are higher in the United States than they are in England for the same professions. So common laborers do better in the United States than they do in England. Carpenters do better in the United States than they do in England. Masons do better in the United States than they do in England. The only group here that's not doing better in the United States than they're doing in England are these machinists who are earning a better wage in England than they would earn in the United States. There's one more table. Okay. Then one last thing. So this is a snapshot in time. This is a particular date. This is 1820 to 1821. So looking at wages in the United States and England, 1820 and 1821. A more interesting question, or another question, I don't know if it's more interesting or not, but another question is what happens to wages over time? So if we look at, oh wait, I skipped a step, I'm sorry. I forgot, I skipped one step. We can use this data, should put my glasses on and read my notes. We can use this data from table 10 to compute a skill premium so that we can take this and divide the skilled wages by the unskilled wages. And so then instead of having a premium for living in the city, we're going to have a premium for being a skilled worker. Skilled wage, unskilled wage. There we go. So the skill premium is defined as being that ratio. It's not the difference, it's the ratio of the skilled to the unskilled wages. And we can compute this skill premium. We could use any of these numbers. Okay. I have to erase all this because I don't have enough room. So there it goes. Erase all the ink on this slide. There we go. All right, here's what we're going to do. We've got that the wages of skilled workers in the United States are, let's take these machinists so I can use the numbers that are in my, no problem, that are in my notes. The wages of skilled workers, SK for skilled in the United States, let's use 114. And that means that it's equal to 1.14 times the wages of skilled workers in England. So the wages of skilled workers in the U.S., just using that one number for the ordinary machinist. I just have to choose a number. I could use a different number, but my notes already have these particular numbers, and I don't want to do math in my head. Wages for unskilled workers in the United States, I'm going to use this 135, are equal to 1.35 times the wages for unskilled workers in England. So that's just interpreting the table. So a number 114 means that the skilled workers in the United States are earning 14% more than the skilled workers in England, or the skilled wages in the United States are 1.14 times the skilled wages in England. And now I can compute the skill premium, so the skilled wages in the United States divided by the unskilled wages in the United States. And I'm going to take the information that I had right here. So I'm going to have my skilled wages in the United States are 1.14 times the skilled wages in England. And I'm going to divide that by unskilled wages in the United States, which are 1.35 times the unskilled wages in England. So I'm just substituting in. And what do I get? I get that the skilled premium in the United States, so the ratio of skilled to unskilled wages in the United States, which is what I have on the left-hand side, is 1.14 over 1.35, which equals, this is why I want to use my notes because I can't do this in my head, 0.84, equals 0.84 times the skill premium in England. The skill premium in the United States is only 84% as big as the skill premium in England. So if you move to the United States, you'll make higher wages than you would if you were in England. But the bonus for being a skilled worker is smaller in the United States than it is in England. That's what this is saying. Dan. Right. So if instead of choosing this 114 number, if I took and computed a ratio, an average of those numbers and used that instead, right? So we can redo this in a variety of ways. But I wanted to show you this because next I'm going to show you what happens to the skill premium over time. Okay. So we start out using the numbers I used, which was using the low range for the ordinary machinist and the number for the common laborer. I get that the skill premium in the United States is smaller than the skill premium in England. That if you're a skilled worker, you're going to get a bigger bonus essentially from staying in England than you are from coming to the United States. Do you guys have a question? Okay. What happens over time to that skill premium? Over time, that skill premium increases. So the numbers I just played with on the previous slide were 1820 to 1821. Other computations that have been done of that skill premium, looking at the skill premium 1825 and then jumping to 1830s, 1840s, and 1850s, shows a marked increase in that skill premium, particularly in the 1840s and the 1850s. We can use our model of labor markets and our knowledge of some facts from history to explain why that skill premium would have increased over time in the United States. This one is kind of messy. We're going to have two pictures. I'm going to have skilled workers on the left, and I'm going to have unskilled workers on the right. I am going to have different vertical scales. And I'm going to tweak my vertical scale so that my initial wage for the skilled and the unskilled workers winds up being the same number of inches above the origin, even though it's a totally different value. So I don't have the same scale on both of my vertical axes. I'm basically tweaking my scales a little bit so that I wind up with the same inches, even though inches correspond to a different number of dollars. Okay. So on the skilled side, just start out, get yourself some initial curves, wages of skilled workers on the vertical, quantity of skilled workers on the horizontal, on the unskilled, wages of unskilled on the vertical, quantity of unskilled on the horizontal. Get some initial demand, D1, some initial supply, S1, find your initial equilibrium wage, call it WS1, it's the initial skilled wage. Do the same thing on the right, try to wind up with the same wage, and if not, just draw yourself a nice big dot so it looks like it's the same. And call that the wages of unskilled workers, WU1. I can label my quantities here, but I'm going to have so much going on that I'm just not going to label my quantities. Because the story I want to tell is a story about wages. I don't really care about the quantities for the story that I'm telling you, so I'm not going to take time to label the quantities and make the graph too crazy. All right, now what's going to happen? So now what happens is we're going to get an increase in the supply of both skilled and unskilled workers. But what do we remember about the makeup of the immigrants in the 1850s, 1840s and the 1850s? Are they primarily skilled manufacturing workers or unskilled manufacturing workers? Unskilled. So there's lots of laborers, particularly Irish laborers, not very much skilled workers. It's disproportionately unskilled laborers who are migrating. So we're going to get an increase in supply, but the increase in the supply of unskilled workers is going to be bigger than the increase in the supply of skilled workers. So draw an increase in the supply of skilled, S2. Draw a big increase in the supply of unskilled, S2. I could add to this graph as well an increase in demand. I'll write it down. That there's also an increase in demand for both unskilled and skilled workers, but there doesn't seem to be much of a difference in the size of the increase in demand. So the historical evidence seems to indicate that the increase in the demand for unskilled workers is on a par with the increase in the demand for skilled workers. So those things are about the same. So whether I draw those shifts in demand or not, I'm going to get the same conclusion. You can draw them if you want. It's going to make your graph messier. If you don't draw them, it's not going to change your conclusion. I'm not going to draw them because I've got enough going on already. So I'm going to look for the intersection of my second supply curve with my first demand curve. I'm going to dash that over. That's WS2. Intersection of my second supply curve with my first demand curve for the unskilled workers. And look at what's happened. The unskilled wage has fallen a lot. The skilled wage has fallen a little bit. Why do I have a decrease in wages? Because I didn't draw the increase in demand on here. If I'd drawn the increase in demand on here, I would have a small, probably like a small or a big, let's say a big increase in wages for skilled workers and only a small increase in wages for unskilled workers. But I would still have that the skilled wage, where I started out with these things being on a par, now I've got a bigger change